All right, I'm sure some of you will want to see this twice because it was kind of complicated, right? So we're going to go through the second example that's in your notes, and then we're just going to kind of skip the story problem for now. So anyway, what I would like you to do every single time, remember you have to find your lines of intersection system, right? So the first set, I need to eliminate a variable, and I still think, if you look, I'm looking for some equation that doesn't have a coefficient in front of the variable. So once again, I think z is going to be the right choice. But if you look, in this case, for the first elimination, we have to eliminate z by multiplying this one by -2 in order to get them to match. So when I do that, my new system is going to be -x plus y plus 2z equals 7. And the next one, I'm going to end up with -4x minus 6y minus 2z equals -2. So once again, I multiplied by -2 on that second equation to get the same number in front of my variable, but with different signs. So when I add these up, 2z plus -2z cancels. When I add these up, though, I'm going to get -5x, and then a minus 5y is equal to 5. Remember, I can make my life easier. Do you notice how 5 goes into all of these numbers? If I divide the whole thing by 5, I can get just -x minus y equals 1, right? This is going to be my first line of intersection that I'm going to use to solve my system, right? So I need to find my other line of intersection now. So the second one that I'm going to do, let's try purple. We're going to use the other equation with this middle one, right? And in this case, they are the same number, but I just need them to be opposite signs. So with this purple system that I'm going to use, all I need to do is multiply that top equation by -1 in order to make this one a -z and that one a positive z. When I do that, though, my new system becomes -2x minus 3y minus z equals -1. The other one stays exactly the same. So when I add these up, my z's will cancel. -2 minus 3 is going to be -5x. I get -7y. And then I get a positive 3. I don't see any common factors, so I'm just going to leave this equation as it is for my second line of intersection. So if I'm trying to solve my line of intersection system, let's just do that in teal maybe. I'm going to use those two equations in the boxes. -5x minus 7y equals 3, and then -x minus y equals 1, and I'm going to have to eliminate a variable. So I see this one, they're both negative, so I'm going to have to make it positive by multiplying by -1, but they also don't have the same coefficient in front of it. So if I make this -5, -5 times -1 would give me a positive 5x, and then I could eliminate that, right? So let us change our second equation here. If I'm rewriting this system, that -5x minus 7y equals 3 is going to be the same, and then the second equation I multiplied by -5 to get a positive 5x, and then I should get a positive 5y, and then I'll get a -5 here. When I eliminate a variable in my line of intersection system, I'm going to get -2y is equal to -2, which means my y is equal to -1. I have my first piece of my 3-coordinate system. I need to move on to step 4, which is where I have to plug y in to one of my lines of intersection. Once again, I'm plugging in y into one of my lines of intersection. I'm going to choose negative x. Oop. Do you see what I did wrong here? This should be a positive 1. Negative 2 divided by negative 2 is a positive 1. Please fix that. Okay, moving back, if we have negative x minus y equals 1, all right, everybody, so I accidentally plugged in negative 1 here. So once again, if we had a positive 1 for y, I plug that in where I see a y. Negative x minus a positive 1 is just like subtracting 1, right? So if I do the opposite and I add 1 to both sides, 1 plus 1 is 2, and then I have to divide by negative 1 to get x as negative 2. That final step, so step number 5, is we have to plug our x and y into an original equation. Any of the 3 will work. I'm going to choose the first one, so negative x plus y plus 2z equals 7, and we're just going to see how things go, right? So if x is negative 2, and then we have y is 1, oops, we're going to have to solve for z, right? If we have, once again, x is negative 2, y is negative 1, we still have to find our z. Double negative actually makes this a positive 2 plus 1 plus 2z equals 7. 2 plus 1 is 3. The opposite of adding 3 is subtracting 3. So we get 2z equals 4, and we divide by 2 to get z equals 2. The last thing that we have to do is write our final answer as a coordinate. So if x is negative 2, y is 1, and z is a positive 2. If you are looking at your story problems, right, all they're going to do is this would be x, this is y, this is z. X, y, z. Okay, you're going to have to figure out how to solve for x, y, and z here, right? It's just like a system of equations where you're adding up points, right? And then you're going to have to eliminate a variable, okay? And then you'll have to work from there, okay? All right. Good luck on your homework.